Um, most of you might have heard of this word algebra, and you might have dealt with lots of these algebraic expressions where we use a square, b square, c square, and or the use of the variable x. And I'm pretty sure that many of you also might find it very intriguing to work with algebra. So today what we'll do is we will have maybe just enough time to look at three different aspects of algebra. One will be on progressions, the second one on linear equations, and the third one on quadratic expressions or quadratic equations. We might have some time to solve some problems also, or we will spend some time looking at the types of questions that can be asked in NTSA as well. So let me start off with the first topic of algebra, that is progressions. Now, if you go to higher grades, this topic is also referred to as sequences and series. But for now, I'll just refer to it as progressions. Now, in progressions, we have three different varieties. One is arithmetic, geometric, and third one is harmonic progression. But before we jump into the definitions of each of them, you have to remember that progressions are a special type of a series. A special type of a series, basically it is a sequence of, or it is a systematic arrangement of numbers, randomly chosen numbers, which have a set of properties. Now, for example, if I ask you 1, 2, 3, 4, 5, and if I ask you what is the next number, what would your answer be? You, in all likelihood, you will be in a position to sort of predict that this might be 6, the next number might be 7, and so on. If I just change this 1, 3, 5, 7, then what will be the next number then? What would you expect the next number to be? Yeah, so you would then expect this number to be all the odd numbers. So after 7, you would expect 9 to follow, right? Or if I have 1, 4, 9, 16, 25, and so on, what will the next number be now?
36.
Yes, 36. And how are you able to predict that?
By squaring each natural numbers.
Yeah, so by squaring each of the numbers, you are guessing that you will get the next number, right? Now, if in each of these cases, if you observe, I can write a generic form to this. Now, this is just n, which stands for the nth natural number. Here, the generic form can be written as 2n minus 1. So if you substitute n is equal to 1, you will get the first one. If you substitute n is equal to 2, you will get the second number, and so on. And here the generic number is n square, right? So similarly, you can think of all types of scenarios. Maybe you can look at this 2, 9, 28, 65, and so on. What do you expect the next number to be? Yes, what do you expect this next number to be? Can you see that this number follows this pattern n cube plus 1? So 1 cube plus 1, you got 2, 2 cube plus 1, you got 9, and 3 cube plus 1, you will get 28, and so on.
126.
Yeah, the next number would be 126. The number after that would be 217, and so on, right? So The idea here is we are choosing numbers, real numbers, and sort of arranging them in a particular sequence. And there is a repetitive pattern there. Right? Now, if you observe by how much are these numbers changing, like if I ask you from here to here, by how much is this number changing?
1.
Yeah, it is changing by 1. From here to here,
1.
again 1, 1 again, and 1 again. Right? So from one number to the other, this number is constantly changing by 1. But look at this scenario. By how much is this changing?
3.
3. What about this?
5.
5. 9 to 16?
7.
7. 16 to 25?
9.
9. So can you guess what the next number would be? By how much would the next number change?
11. 36.
Yeah, so you would expect the next number to change by 11. Right? So you can always say that you will get the next number by adding a certain number which is predictable, right? In the first scenario, it was always fixed. It was always 1. In the second scenario, here it was predictable. The number is changing from 3 to 5 to 7, 9, 11, basically odd numbers, right? But if you look at this, by how much is this changing?
7.
This is changing by 7. What about this?
19.
19. What about this?
47.
47. And if you get the next number 126, then it would be 61. Right. So here you will see that there is no pattern emerging. 7, 9, 47, 61. Right. So depending on how these numbers change, depending on this particular pattern, these series of numbers, there are 3 special cases. Right. All the cases that we will be studying about are special cases. So the first one is called as an arithmetic progression. Okay. The arithmetic progression is one in which the difference from one number to the other is always constant. Meaning, so if you have the first number as A, the next number would be A plus D. Right? Now, by how much have we changed this?
D.
It has increased by D. Right? The third number would be A plus 2D. So by how much is it changing?
D.
Again D, right? The fourth number would be A plus 3D. By how much is it changing again?
D.
Again D. So if I were to write the generic form, like in this case, I have written n, 2n minus 1, n square and so on. So if I were to write the generic form here, I would write it as A plus n minus 1 into D. Am I right? So if you substitute n is equal to 1, you will get A. If you substitute n is equal to 2, you will get A plus D and so on. So the nth term in this sequence can be predicted as A plus n minus 1 into D. Right? So this particular A, the value A, is referred to as the first term, which is very straightforward. We know that the first term is fixed, that is A. This D is what is called as common difference. Any idea why it is called as common difference?
Because the difference between all the terms is consecutive terms is always common.
Exactly. So if you take each of these terms, if you subtract it from the previous term, the difference is always fixed. Now, common difference can be positive, common difference can be negative. Similarly, first term can be any real number. It is not necessary that it has to be an integer or anything. Okay. Now, there are a lot of quantities or there are a lot of properties which arise out of these arithmetic progressions. Okay. Now, let me give you one simple example. Let me give you just one simple example. Now, let's say you are given a scenario where you have to add the numbers 1, 2, 3, 4, and 5. If I say add all these numbers 1 to 5, what will you do? Or how would you calculate? You would add each of them. You will say 1 plus 2, 2 plus 3, 3 plus 4, 4 plus 5, and so on, right? So what would the sum be?
15.
It will be 15. Yes, right? But if I say now adding till 5 is not enough, add till 10. Then what would you do? Then you will go on adding 6, 7, 8, 9, each of them, right? Now, if I make the problem much more complicated, if I say add the first 100 numbers, then the problem is no longer straightforward. It is slightly more tricky, right? So one of the methods, counting methods which we use is if you have to add the first, let's say the first 10 numbers. So 1 to 5 we have written. You will now write down 6, 7, 8, 9, and 10. And observe that I am writing in the reverse order. Okay. Now, if you add these numbers, what will you get?
11.
So you will get 11 here. What about these two?
11.
Yeah. So I have written these numbers in such a way that when I add them, you are getting the same sum. Am I right?
Yes, sir.
So you will get 11. How many 11s will you get?
5.
You will get 5 of those 11s, right? And how do you know that there are 5 11s? In this case, you are able to count. But if I say add the first 100 numbers, how will you say that how many pairs are formed like this?
50.
50 pairs. But how are you saying it is 50 pairs?
100 numbers, each number, two numbers get one pair, so there are 50 pairs.
Yeah, so what you have done is you have taken all the 100 numbers and you have sort of roughly divided them into or divided that number by 2, right? So this, when you calculate the sum, you will say that it is 11 into 5 pairs. So total sum is 55, right? So
Yes.
this is a very, very interesting property. If you observe, what we are doing is we are adding the first term, we are adding the last term, and then we are multiplying by the number of pairs. Am I right? So whenever you are given any arithmetic progression, one of the interesting properties which is usually you are asked to calculate is the sum of n terms, which is if you have a, next a plus d, a plus 2d, and so on till a plus n plus 1 into d. So if you have to add all this, what would what you will do is you will just start forming those pairs. So what will you do? You will write a plus d, a plus 2d, and then write the other terms in the reverse order. A plus n minus 1 into d, a plus n minus 2 into d, a plus n minus 3 into d. So can you see how these pairs are formed? So this is one pair. And what is the sum of this pair?
2a plus n minus 1 whole into d.
2a plus n minus 1 into d. What about this? This is also 2a
2a plus n
plus,
minus 1 whole into d.
correct? So
Yes,
how many such pairs are there? How many
n
such
by 2.
pairs are? N by 2 pairs are there. Correct? So if you now add, can I say this is 2a plus n minus 1 into d into n by 2 pairs?
Yes, sir.
So this is what is said as the sum of n terms in an arithmetic progression. Okay, now just let's see some simple scenario where we can apply. Now suppose they ask you sum of 10 natural numbers. Now the moment I use the word natural numbers, what does it tell us? It tells us a is equal to 1, d common difference is equal to 1. Am I right? So the sum of natural numbers Sn will be, what is this 2a? 2 into 1 plus n minus 1 into 1 into n by 2. Now if you simplify this, you will get 2 plus n minus 1. So what will you get? You will get n into n plus 1 by 2. Okay. Now if you want to calculate the first 10 natural numbers, S10 is equal to 10 into 11 by 2, which will be 55. That's what we had got earlier. Am I right?
Yes, sir.
Now suppose I ask you, what is the sum of the first 10 even numbers? Starting from 2. How will you calculate?
N is equal to 10, D is equal to 2, and A is equal to 2.
Yeah. So the first number, you are expecting it to be 2. The common difference between all those numbers, again you are expecting it to be 2. Then you will substitute those. Okay. So remember that all these arithmetic progressions are basically sequences of numbers where there is a common difference, or the difference between the numbers remains constant. Okay. Now there is another interesting property which we sort of make use of quite a bit. Now if you observe a plus d and a plus 2b, can I now say that these three numbers are in an AP, arithmetic progression?
Yes, sir.
Because,
Yes, sir.
because their difference is the same, right? Now, if you calculate average of a and a plus 2d, the first term and the third term, how will you calculate the average? You will say a plus a plus 2d divided by 2. So a and a, you will get 2a in the numerator, 2a plus 2d. So if you simplify, you will get a plus d. So the number which you are getting as an average of a and a plus 2d is the middle number, is the second number. So this is also called as arithmetic mean. This is a term which we repeatedly use almost synonymously, yeah, equating it to average. Mean. Mean means it is a term or it is a number between two numbers such that all the three numbers will be in an arithmetic progression. Okay. So if you are given two numbers A and B, the difference between these two numbers will be B minus A. This is the difference between these two numbers.
Yes, sir.
So this number which is going to be there at the center, let's say this is C. C minus A will be equal to half this gap. So half of B minus A. Am I right?
Yes, sir.
So you will be able to, and if you simplify, you will get the same thing. See, if you just simplify this, if you bring this A to the other side, you will get C is equal to half of A plus B, which is what we started with, right? So this arithmetic mean uh, is B minus C. The gap between B and C is equal to half of B minus A. So you should be able to sort of write this equation, right? Sometimes you are asked to introduce more than one arithmetic mean, meaning you have A, you have B, you are asked to introduce C1 and C2, two numbers. So how many gaps are there now? This is one gap,
3 gap.
this is two, and this is three. So you can say that C1 minus A is equal to 1/3 of B minus A. Am I right in saying this?
Yes, sir.
Or you can say C1 is equal to A plus 1/3 of B minus A. Similarly, if you have to write C2 minus C1 will be equal to 1/3 of B minus A. So C2 will be equal to C1 plus 1/3 of B minus A. Now going by the same logic, you will write C3. We don't have C3 here. This will nothing but become B here. Will be equal to, again, C2 plus 1/3 of B minus A. So they both will become equal. Okay. So if you are introducing you can actually introduce any number of arithmetic means. If it is not mentioned, it means that you are just introducing one number. So that gap which is there, you are dividing it into two pieces. By introducing one number in between, you are dividing it into two pieces. Okay. So many times there are questions are asked around this, around what is an arithmetic mean. Okay. Next, another type of a progression where there is some again progression is a special case, right? So another case of progression where you can predict the next term is a geometric progression where you are multiplying one number with the other continuously. So if you have a number A, the second number is AR, third number is AR square, fourth number is AR cube, and so on. And if you observe, the last number would be AR to the power of n minus. So here A is again referred to as the first term and R is referred to as the common ratio. Now, in the case of an arithmetic progression, we were subtracting these two and two consecutive terms, and we were saying that it is common difference. Here, in the case of a geometric progression, you are multiplying. So if you divide those two terms, two consecutive terms, what you will get is the common ratio. So here in the geometric progression, the nth term would be a into r power n minus 1. So if n was equal to 1, the first term will be equal to a into r power 0. R power 0 will become 1. So you will get a. Second term, n is equal to 2. You will write a into r power 2 minus 1. So that will be equal to a into r, and so on. Okay. Now even here, you will be asked to calculate the sum of terms. So let me just show you a couple of scenarios. Let's say sum of first two terms, a plus ar. You will write it as a into 1 plus r. Now suppose you calculate the sum of first three terms, a plus ar plus ar square. If you take a common, 1 plus r square. Have you seen this part's number somewhere? 1 plus r square somewhere? Anyone? You might be able to recollect that if you had, let's say, 1 minus r cube, you would have written this as 1 minus r into 1 plus r square. Or you would have written this, a cube minus b cube is equal to a minus b into a square plus ab plus b square. Isn't it? So in this case, if you write a is equal to 1 and b is equal to r, what you are writing here is the same thing, right? So if you write a square plus b square plus ab plus b square is equal to a cube minus b cube divided by a minus b. Now in this scenario, a is nothing but 1 and b is nothing but r. So the first term a square is nothing but 1 here. ab is 1 into r. R you have. B square is r square here. So can I now write this as a into 1 cube is 1 only minus r cube divided by 1 minus r. Right? Now just by going forward, like you can also, if you observe this, I can also write this as 1 minus r square by 1 minus r. Why am I writing that? Just to show you one more pattern. If you write it till n terms, a into 1 minus r power n divided by 1 minus r. So the sum of n terms in a geometric progression can be written as a into 1 minus r square, 1 minus r power n divided by 1 minus r. Now again, this is something which you will be able to apply and check for yourself, right? Now let's take a geometric progression like a case where, let's say you have this geometric progression 2, 4, 8, 16, 32, and let's say till 64. So 6 terms you have taken. So n is equal to 6. First term is equal to 2. And the common ratio r is equal to 2. Right? Now you just manually calculate this. 2 plus 4 is 6. 6 plus 8 is 14. 14 plus 16 is 30. 30 plus 32 is 62. 62 plus 64 is how much? You'll get 126. Right? Now let's check, are we getting that 126 or not? Yes, 6 is equal to a 2 into 1 minus 2 to the power of n. So 2 to the power of 6 divided by 1 minus 2. Okay. Now if you observe, what is 2 to the power of 6? 2 to the power of 6 is
64.
64. Yes. 1 minus 64 is
Minus 63.
minus 63. In the denominator, you have minus 1. So minus and minus will get cancelled. You will still get 126, which was the same answer that we had started out. Okay. So in the case of geometric progressions, it is important that you understand that these numbers, there is a particular pattern in which they occur. Okay. Now, just as we had introduced an arithmetic mean, what was the arithmetic mean? In the case of an arithmetic mean, we said if there are two numbers, A and B, if we introduce a number C such that A, C, B are in an arithmetic progression, then C is said to be the arithmetic mean of A and B. Correct? So similarly, now if C is introduced such a way that A, C, B are in geometric progression, then you will say that C is the geometric mean, right? Now, if C is the geometric mean, isn't it true that the ratios are equal? Meaning C by A should be equal to B by C.
Yes, sir.
Now, if you cross multiply, you will get C square is equal to AB. So C is equal to plus or minus square root of AB. Okay. Now, what is the common ratio here? The common ratio will be equal to C by A. So if you take C by A, you will get square root of B by A. Similarly, if you want, you can introduce multiple geometric means. Okay, it is not necessary that you have to introduce only one geometric mean. You can introduce multiple geometric means as well. Okay. The third interesting type of progression is called as a harmonic progression. The harmonic progression is one scenario where if you take the reciprocals, let's say if you say A, B, C are in HP, are in a harmonic progression, what it means is this implies that their reciprocals 1 by A, 1 by B and 1 by C are in AP. Okay. Now, if these three are in AP, can I write that the difference between consecutive terms 1 by B minus 1 by A is equal to 1 by C minus 1 by B?
Yes, sir.
So if you get this term to this side and if you move this to this side, so you'll get 2 times of 1 by B is equal to 1 by A plus 1 by C, which is nothing but A plus C by AC. Or if you just invert the entire thing, B is equal to 2AC by A plus C. So in this case, B is the harmonic mean of A and C. So if you observe, whenever you have to calculate the harmonic mean, you just have to start with assuming that the reciprocals are in arithmetic progression, and then you calculate. Usually, not many questions are asked around the harmonic progression, but it is important that you know that concept. There are a lot of questions which are usually asked around the geometric and arithmetic progressions. Okay, any questions at this point? No questions? Okay. Now I want you to go back and calculate few simple scenarios. Let's say they give, I'll give you one scenario where this similar problems can be applied elsewhere. Let's say in a triangle ABC, the three angles are in AP. Find the angles. So how will you do that? If the three angles are in AP, how will you calculate?
Sir, we can take the three angles as A plus D and A minus D, and A plus D plus A minus D is equal to 180 degree. So D and minus D cancelled. So 3A is equal to 180 degree. A is equal to 60 degree.
Yeah. So there are two ways of starting this. One is you can assume that the three angles are A plus D, and A plus 2D. Now, if you add all these three angles, what will you get? You will get 3A plus 3D,
इस बच्चे की तबीयत खराब है, इसका क्या
or
करना है? आज
3 times
आप
of A plus
एमओबी हो
D
घर में नहीं
is
है
equal to
घर
180 degree.
वाले तो
So if you simplify this, you will get A plus D is equal to 60 degree, or the central angle will be 60 degree. The other way of sort of simplifying this would be to assume that the angles are A minus D, A, and A plus D. So if you observe here also, they are in arithmetic progression only, right? Now when you calculate their sum, what will happen is this minus D and plus D will get cancelled. You will only be left with 3A. 3A is equal to 180 degree. So automatically A will become equal to 60 degree. This is what Shika was mentioning, that the central angle will be 60 degree. However, you don't have another equation to calculate the value of this common difference D. For that reason, you will not be able to accurately tell what the angles are unless there is another condition given. But you can tell what is the central angle, right? Similarly, if it was given that the three angles, if the three angles are in GP, how will you calculate? If the three angles are in GP, how will you calculate?
A plus AR plus AR square is equal to 180 degree. So
Yeah.
A whole into 1 plus R 1 R square is equal to 180 degree.
So you will write this down like this. A plus AR square is equal to 180 degree. So automatically you will write A into 1 minus R cube divided by 1 minus R is equal to 180 degree. Now you have two variables in this equation, but you require another equation to solve solve this. Same scenario like in the earlier case. But being able to write this equation first, a plus ar plus ar square is equal to 180 degree. That's an important starting point. Similarly, when they have given that it is an arithmetic progression, writing a plus ad, a plus d plus a plus 2d, if you are able to mention those three terms, then that's the starting point. From there, you will be able to solve the problem, right? So sometimes they also give you uh, the volume of a cuboid is so and so number, and then they'll tell that the length, breadth, and the height are in an arithmetic progression. Calculate the values. Okay. Or there is a very interesting question which was asked in one of the NTSC exams earlier, is that in a right angle triangle, the sides are in an arithmetic progression. What is the ratio of the sides? You can try this at home. If in a right angle triangle, the sides are in an arithmetic progression, you are expected to calculate the ratio of the three sides. Okay, so try this at home, and then in case you have a doubt, you can mention it to me and we'll discuss it in the next class. Okay, now let's move to the second important topic, that is on quadratic equations. Okay, now what is a quadratic term, or when we use the phrase quadratic, what do we mean?
The equation which has a degree 2.
Yeah, so whenever in any expression, in an algebraic expression, if the degree is 2, then we use the phrase quadratic. And if it is an equation, if it is equated to something, then we use the term quadratic equation. Okay, so if you have any expression like this, let's say you have f of x is equal to ax square plus bx plus c. This is what is called as a quadratic expression. Now, if you had written ax square plus bx plus c is equal to 0, then this would have become a quadratic equation. Okay. Now, whenever you have quadratic equations, you should observe how they are represented. Okay. Now, let's say you have x square plus 2x plus 1 is equal to 0. Okay, this is a quadratic equation, right? Now, what does this tell you? The moment you write down this equation, what does it tell you?
It has 2 roots.
Yeah, it has 2 roots. Okay, what else? What else does it tell you? So whenever you are given this, remember that first you take this expression y is equal to x square plus 2x plus 1. Okay, now make a table x and y. Let's say you substitute x is equal to 0. What will you get? Y? You get 1?
3. 0, 1, 1.
Yeah. If you substitute x is equal to 1,
3.
y will be equal to 4. If you substitute x is equal to 2, what will you get?
9.
9. Yes. If you substitute x is equal to minus 1, then
0.
you will get
0.
0. Yeah. If you substitute x is equal to minus 2, you again get 1.
1.
Yeah. So let's plot these points. So let's say this was a x-axis and y-axis. Let me do it approximately. I am not very keen on getting the accurate answers, accurate graph. So this is 0, 1. This was the first point, right? The second point 1, 4. So if this was 1, this would have been somewhere here, 1, 4. The third point was 2, 9. So if this was 2, 9 would be somewhere here, 2, 9. Next, minus 1, 0. So this would have been minus 1, 0 and minus 2, 1. So this would have been minus 2, 1. Now remember, if you join these points, and usually we draw what is called as a smooth hand curve. We are not drawing straight lines here. We are drawing a smooth hand curve. So can you see that this looks like a bucket?
Yes,
So
sir.
this particular shape is what is called as a parabola. So a quadratic expression, when you write down this x square plus 2x plus 1, this quadratic expression is represented by a parabola. Okay. Now, when you are saying that it is equal to 0, the moment you convert that into an equation, what it means is you are drawing the x-axis and you are now observing where is this x-axis cutting this graph or cutting this curve or cutting this parabola. In this case, if you observe, it is just cutting at one point. So the places where the x-axis cuts this graph are called as the roots. So in this case, the roots are equal. Okay. So let me give you multiple scenarios. If the graph was like this and this was the x-axis, then you would have mentioned there these roots are real and they are unequal. If this was the graph and the x-axis was just touching like this, in this case you would say these are real and these are equal. If the graph was like this and this was the x-axis, here you will say these are imaginary roots. Imaginary roots. There the curve is not cutting the x-axis at all. Right? So whenever you are given any quadratic equation, you can always check whether there are real roots or a imaginary root. So one way of finding out is, suppose you are given this ax square plus bx plus c is equal to 0. We define what is called as the discriminant d, capital D. This is equal to b square minus 4ac. Now if d is greater than 0, then you have real unequal roots. If d is equal to 0, then you have real equal roots. If d is less than 0, then you have imaginary roots. Now just check, in this case you had x square plus 2x plus 1, no? So if you take the scenario x square plus 2x plus 1 is equal to 0, what is the discriminant here? What is the discriminant here? What is the
0,
value of b here?
2,
Yeah, so b square will be
4,
4. Then what about a?
1.
And C?
1.
Yeah, so B square minus 4AC is
0.
0, correct? So this, we had earlier drawn this graph and we mentioned that the roots are real and equal. So we have got that here. Now I'll keep on writing down some equations. I want you to tell me whether those roots are real or equal or imaginary, whatever you can tell about the roots. Okay. So let's take this 2x square plus 2x plus 4 is equal to 0. 2x square plus 2x minus 4 is equal to 0. X square minus x plus 1 is equal to 0. X square minus 8x plus 15 is equal to 0. So can you calculate the discriminant in each of the cases?
Yes, sir.
Yeah, so what is the discriminant in the first case?
Minus 28.
Minus 28. So what will happen to the roots?
Imaginary roots.
Yeah, so the roots are imaginary. What about the second case?
36.
It will be plus 36. So the roots are
Real and unequal.
real and unequal. Okay. What about the third scenario?
Minus 3.
Minus 3. Right. So
Imaginary.
what about the roots?
Imaginary.
Imaginary. Okay. And what about the fourth one?
4. Real and unequal.
Real and unequal. Okay. Okay. So similarly, given any scenario, you can always calculate or find out whether your equation has real roots, unreal roots, imaginary roots. You should be able to predict all of it. Okay. Now, another interesting property is when you are writing this equation, a square, ax square plus bx plus c is equal to 0, the sum of the roots will always be equal to minus b by a, and the product of roots will always be equal to c by a. Okay. Now, if I ask you in the fourth equation here, what is the sum of roots?
8.
8. And what is the product of roots? 15. So in this case, one of the things you would have done earlier is you take this number, you will factorize it, right? You will write down what the factors of 15 are: 1, 3, 5, 15. Then you will see, you look at this 8. Can it be written as a combination of these two? Then you will write x square minus 3x minus 5x plus 15 is equal to 0. So in the first two terms, you will take x common, x minus 3 minus 5 common, again x minus 3 is equal to 0. So if you take x minus 3 common now, you will get x minus 3 into x minus 5 is equal to 0. So from this, the moment you write this down, what are the roots here?
X is equal to 3 and 5.
3 and 5. Yeah, so 3 and 5 are the roots. So what is the sum of roots?
8.
8. Right? So it is a verification of what we have already calculated. What is the product of roots?
15.
15. Yeah, 3 into 5 will be 15. Right? Now, wherever possible, you can calculate the roots of a quadratic equation by factorizing it this way, the method I have just shown. But it might not always be possible. For example, look at this equation. x square plus x minus 2 is equal to 0. Can you factorize this? Can you factorize this equation? You have to first look at the factors of this minus 2. So factors of minus 2 can be minus 2, minus 1, 2, 1. All these are possible factors, right? So can you write this x square plus x minus 2 as x square plus 2x minus x minus 2 is equal to 0. If you take x common now, x into x plus 2 minus 1 common, x plus 2 is equal to 0. Now if you take x plus 2 common, x plus 2 into x minus 1 is equal to 0. So what are the roots now?
Minus 2
1 and minus 2.
Yeah, 1 and minus 2. So sum of the roots is? Sum of the roots is 1 plus minus 1 is the sum of the roots, right? From the equation you also will get the same thing. And product of the roots is?
Minus 2.
Minus 2. Great. Now, if this was just one change, if I just make this, how will you solve this now? Instead of x square plus x minus 2 is equal to 0, if this was just x square plus 4x minus 2 is equal to 0, how would you solve this?
By using discriminant.
By using discriminant, okay, let's calculate the discriminant. B square, which is 4 square minus 4 into the value of A is 1 here and value of C is minus 2. So 4 square is 16. 16 plus 8, discriminant is equal to 24. So we know that this has real roots, right? This has real and unequal roots. But how will you calculate those real and unequal roots?
by quadratic formula.
Equation.
Yeah, so one way of solving this is by equation. The other way of solving this equation is by drawing a graph and then seeing where it cuts the x-axis. And the third way is to compare this equation. If you were given ax square plus bx plus c is equal to 0, the two roots will be minus b plus square root of b square minus 4ac by 2a. This is one root. The second root will be minus b minus square root of b square minus 4ac by 2a. Now, if you observe what is there inside the square root, b square minus 4ac is nothing but the discriminant.
Discriminant.
So together we just write this equation as minus b plus or minus square root of the discriminant divided by 2a. So if you use plus, you will get one of the roots. If you use minus, you will get the other root. Okay. Now you will also see that the moment you add these two roots, you will again get back the minus b by a form. If you multiply these two roots, again you will get the c by a form also. So that you can try at home, and you can also solve multiple quadratic equations which you have been given so far. Okay, any questions at this point? Any questions at this point? Okay, so if there are no other questions, I'll stop here. I also wanted to discuss the third concept of linear equations in multiple variables today, system of linear equations. Unfortunately, we don't have enough time for that, but I'll take it up in the next session. So we'll stop here, and like I had mentioned, go back and try some of the concepts which I mentioned here. And in case you have a doubt, we can discuss in the next session. So one concept, that is systems of linear equations as well, we will discuss it in the next class. So over to you, Maitri.
Thank you, Praveen. Thank you everyone for joining the session. I